Welcome back. In this short lecture, we will be dealing with semantic tableaux method concerning particularly solving lady or tiger problems. There is another interesting set of problems. These puzzles are cooked up by Raymond Smullyan, and you will find these puzzles in the book Lady or the Tiger. That is the title of the book. So, these problems are very interesting in a sense that the description of this puzzle goes like this. A prisoner wants to punish a king wants to punish his prisoners, and then before punishing them he is giving them some kind of alternatives. He is a generous king, so he says like this. Let us consider the first puzzle and then how we solve these puzzles by using semantic tableaux method. So, there are two rooms which is showing it to the prisoners, and each room contains, I am talking about the first problem, each room contains either a tiger or a lady. So, if the prisoner finds a tiger, he will be eaten, he will become food for the tiger. If he chooses a lady, he can marry her and then happily live, he will live his rest of his life. So, it so happened that the lady is also considered to be beautiful. So, it is the strategy of the prisoner is always to look for a door in which a lady is present. Nobody will be interested to choose the tiger. So, either there is a lady or there is a tiger in these rooms. It might be the case that the king might have kept only tigers in these two rooms, or ladies in the two rooms, in both the rooms. So, these are the preconditions that we have, and the doors to the rooms bear these signs. So, prisoner has some kind of clues, and using these clues he has to use his reasoning skills to figure out the right thing for the point of view of a prisoner is to find out a door in which lady is present. In some other textbooks it is explained in the sense that same kind of problem, tiger, if he chooses tiger he will be eaten, and there is another one, another door where some kind of grand feast is waiting for the prisoner. So, more or less it is same thing, finding a lady or having a feast you will be set free also in that case. So, now these are the two signboards that a prisoner sees. So, the first one is like this: in this room there is a lady, and the other room there is a tiger. That is what is written on the first door. Room number 1 has this particular kind of thing. In the second door, on the second door we have this thing: in one of these rooms there is a lady, and in one of these rooms there is a tiger. So, you need to represent these two sentences in the language of propositional logic, and then we will be able to manage this thing. So, if the prisoner was given only these two, if he just sees the two signboards, he will not be able to figure out not be able to figure out the correct door. He requires some more clues. So, now then he asks the king, then king is again generous, and he replies like this: one of the signs is considered to be true. That means whatever is written on the room number 1 is true, or whatever is written on the room number 2 is true, etc. That means one of these signs is true, another one is false. If R1 is whatever is written on R1 is true, R2 is automatically false. So, now his prisoner's job will become little bit simpler with this additional clue, that is he also tells which sign is correct and which sign is not correct. The king is so generous enough to tell these things. So, now which room he should choose. So, now this problem can be represented like this. So, before solving this problem you need to first have some kind of representation. So, now let P, some kind of letter P stands for a prepositional variable. It stands for the first room. First room contains a lady. So, this is R1 and R2. Some inscriptions are there here, that is the one which you are seeing it in the slides. So, now let Q stands for there is a the second room contains LED. The second room contains LED. So again it follows two valued logic. The moment you say that not P, that means there is no lady in the first room, and not Q means there is no lady in the second room. So you can talk about a similar kind of thing by referring to only tiger, by saying that if P stands for the first room contains a tiger and Q stands for second room contains a tiger, then not P means first room does not contain a tiger, not Q means the tiger is not present in the second room. In that way also you can represent it. So now let this be our representation. So now how to represent? In this room there is a lady and the other room there is a tiger. So this is represented in this way. So the first statement, in this room there is a lady, in the other room there is a tiger, is represented in this sense. So this is what is written on R1. R1 tells us that in this room there is a lady, that is P, in the other room there is a tiger. Tiger is present means lady is not there. So in the initial description of our problem, either both are ladies, both are tigers. It is not the case that lady and tiger are there. If it is there, then tiger will eat away the lady and then there is nothing left. So P and not Q. So that is the first statement which represents this thing. In this room there is a lady, in the other room there is a tiger. Now the second, on the second door, this is what is written. In one of these rooms there is a lady, in one of these rooms there is a tiger. So this is usually we confuse this statement as P and Q. Actually this is not the case. So in one of these rooms there is a lady means it rules out the possibility that there is no tiger in that room. Lady means there is no tiger and tiger means there is no lady. So this is a kind of exclusive R kind of thing. P exclusively R Q. So it is like either P or Q is the case, but not both of them, P and Q. So that means either lady has to be there or tiger has to be there, but definitely not both the things. So both lady and tiger should not be there in the same room. So in one of these rooms there is a lady, in one of these rooms there is a tiger. So which is written like this, P or Q, but not both of them. So this whole thing is represented as exclusive R. One excludes the possibility of other one. It's like when you go to some kind of party, usually we have some kind of choices, like either you take salad or you take ice cream, something like that. That means if you take some fruit salad or something like that, you are not supposed to take ice cream. So one excludes the possibility of the other one. So now given that this is the description, the other thing is that other thing which is given to us is this thing. One of the signs is true, another one is false. Either it has to be like this, or not R2 and R1. So this gives us an indication that one of the signboard is true, another one is false. In this case R1 is true and not R2 is true. So this we will use it little bit later. So now apply semantic tab blocks method on this one. So this is going to be like this, R1 P and not Q. This is the first statement I am writing it. Not of R1, signboard on R1 is false, then this is the thing, not of P and not Q. So now this is written as P and not Q, and this leads to branch not P, not of not Q is Q. If you just see the one open branch, from that you can study the entire thing. So now this is there is no literal negation does not exist here, the branch is still open. So now we have P or Q, the same formula, and not of P and Q. So this is one formula, and the second one is you have to deny the whole formula. So not of P or Q and not of P and Q. So now this simplifies to this one. So PRQ is written in this sense. It's a branch which leads to this one. So now you simplify this one, it leads to this not P, not Q, because negation of conjunction is disjunction. So this leads to not P, not Q. So the initial description of the problem is gone. Now we are trying to handle or manipulate the symbols. Ultimately we are trying to our journey started with this thing. We are constructing a tree diagram, and ultimately it ends up with atomic propositions. Your atomic proposition tells us whether it is true or not. So now you have P here and not P here, this closes. So now so this branch remains open. Open branches are the ones which you need to inspect it in greater detail. So now you have not P here and P here, this closes, Q and not Q closes here. So we can still expand this particular kind of thing, but we have one open branch. So that is like this. With this you can find out a solution like this thing. We have R1, just we need to see the open branch. Open branch is going like this, R1 P not Q all the way down P not Q. Okay, here you need to write R2 here, because R2 and this formula and not R2 leads to this formula. So we have to have this also. So we have R1 R2, R1 R2 is there, and P not Q all the way down, again P not Q is there, again it is repeating. So that's why we not have to write anything here. So now this is the open branch which satisfies this particular kind of formula. We need to come back to this one. Then so our representation is like this. Either both of them are true, or at least one of the signboard is true, another one is false. So now if this problem is interpreted in a different way, both the rooms, the signboards are true, then this is going to be the solution. But we are not getting the solution here, because we need to look into this particular, one of the signs is considered to be true, the other one has to be false here. So that's why, although this is considered to be a solution for this one, but doesn't satisfy our initial description of the problem. Initial description of the problem, we need to have one signboard true, another one is false, or the other way around is either R1 is true, R2 should be false. If R2 is false, R1 should be true. So this should not be taken as a solution. Now we need to expand this particular kind of branch. So ultimately we need to have R1 and not R2. So this goes, so now this is a not of PRQ, and not of not P and Q is this one. Not P and Q is P and Q. So it is written like this. So now not Q and Q closes here, and this is a branch which leads to, sorry, this leads to not P and not Q. Even this branch also closes. So now since this problem could be solved only although we have an open branch here, this is not giving us a solution here, because one signboard has to be false there. So since we did not achieve this thing, now we need to go into the details of the second branch. So I will describe one problem and then I will stop it here. So now in this case, not R1, now we need to write the entire thing here. This problem will be solved, it would have been solved when the king had said, provided he had said this particular kind of thing. If both signboards are true, then this is the solution. So if both signboards are true, R1 R2 are true, then P and not Q means this one. P means lady is in the first room, not Q means lady is not in the second room. So that is going to be the solution. But in the initial description of the problem, it is mentioned that one of the signboards is true, another one is considered to be false. So that is not serving our purpose. So now we need to get into the second one. Just I will close this particular kind of thing, then I will expand this branch. Then we will see whether we will get to know the answer. So now this is the one which we are writing, R2 and the same thing, PRQ and not of P and Q, and then not R2, that means the signboard R2 is false, and then this is negation of P R Q and not of P and Q. So let us consider this particular kind of thing. So this is P R Q and not of so this is P R Q. P R Q is simplified into this one. Not of P and Q is simplified as not P, not Q, not P, not Q. Let us see whether any open branch is open or not. So now P and not P closes here, not Q all the way down here, it does not close, it remains open. So this also remains open. Now Q and not Q closes here. So now here is another set of solutions that we have. So that is like this, not R1 all the way down like this, we have not P, and R2 is the one which we have, and then P and not Q. This closes here itself because P and not P is there. So this cannot be the solution. So now the solution for this one is this one. So this closes here itself. So now the other one is not R2, sorry, not R1 and not P, all the way down here R2 and then Q and not P. So now this satisfies our initial description of our problem. So in the initial description of our problem, one of the signboards needs to be true, another signboard needs to be false here. Here R2, one signboard R2 is true and the other signboard R1 is considered to be false. Now this seems to be the adequate or satisfactory solution which fits into our description of our problem. So that means here Q and not P. That means Q means lady is in the second row, not P means lady is not in the first row. So that means the prisoner has to choose the second door. So in the initial description of the problem, these two rooms are given to him and some inscriptions are given to it. So now the prisoner has to choose the second room rather than the first room. So in this way, once you have a problem, you have problems like this, you need to represent it appropriately into the language of propositional logic, and given the description of the problem, then you can solve in which door lady is there or in which door tiger is there. So prisoner's life would have been miserable if the king had not given clues like this thing. One of the signboard is true, either both the signboards are true, or these kind of clues are not given to the prisoner. There is no way in which you can figure out the right door. The right door for him is the door in which lady is there or grand feast is waiting for him. So I will stop here. In the next class we will be dealing with introduction to modal logic, where we will be talking about the syntax, semantics, etc., and then we will be dealing with normal modal propositional logic. So I will stop here. Thank you.